right, guys, need a note sheet. Everybody has a note sheet for 3.11. Everybody has the 3.11 note sheet, yes? So what we're doing in chapter 3 is we're going over quadratic equations. And the main form that these quadratic equations are going to come in is in the form ax squared plus bx plus c. Standard form. We've covered these quadratics. Chapter 2 mainly revolved around different parts of the quadratic equation, but we're going to be delving a little bit more into this with solving, factoring, actually finding the values of x that make the function be 0. We're actually solving these than just talking about the parts, because all of chapter 2 was talking about the focus, the vertex, finding the equation from the given information, or finding information from the equation. And one of the first ways that we're really going to look at with solving is going to be factoring. So we're going to go through factoring and understand how to factor quadratics before we start solving it by factoring. Now, factoring, this isn't in your notes, is going to be the opposite of the distributive property, our FOIL, multiplying out. Because if we're given, say, 4x minus 5 times x minus 3, the first thing we're going to do is multiply through by our 4x. We're going to do 4x times x, which would give us 4x squared. Then we'll do 4x times negative 3. 4 times negative 3 would be negative 12, and we still have our x. Next thing we're going to multiply through by is negative 5. So we'd say negative 5 times x is negative 5x. And negative 5 times negative 3 would be positive 15. Last thing we'd have to do is combine like terms. 4x squared does not have any like terms. But our negative 12x minus 5x would combine to give us negative 17x plus 15. And we know how to do this. We know how to multiply through to get to this here. Now, what we're going to be doing with factoring is taking it from 4x squared minus 17x plus 15 back to 4x minus 5 times x minus 3. We want to factor it back out. Now, there are some main steps in doing this here. And that's what we're going to be looking at. The first step in factoring is greatest common factor. We want to factor out the greatest common factor. If a is negative, factor it out. So if there's a greatest common factor, there's a number in common with all three terms, we're going to factor it out. If a is negative, if that first number is negative, we factor it out. And if there's a number in common and a is negative, we factor it out. So first is our greatest common factor. If a is negative, factor out the negative. Because we really want to get rid of any common factors across all three terms. We want to pull it out. We want to factor it out. And we want to make sure that the first term, a, is positive. It's going to make things a lot nicer and a lot easier. So the first thing we do when factoring is to find the greatest common factor. After we find the greatest common factor, we're going to write two sets of parentheses with 3 spaces. We want to have 2 sets of parentheses with 3 spaces. Now, our 3 spaces is more just to help us space the parentheses out. Now that brings us to step number 3, to find the signs. In each of these sets of parentheses, we will have 2 terms and a sign in the middle. Now the signs can be one of 2 things. They could either be plus or minus. We're either going to add the 2 terms or subtract the 2 terms. We're not actually going to simplify it. We're just going to have a plus or minus between them. And the way we can do this is based off the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is positive, the signs are the same and match the sign of the middle term. Because the only way that we can get that third term to be positive is if the signs of the two factors are going to be the same. Because a negative times a negative is going to be a positive. A positive times a positive is still a positive. So if the third term is positive, the signs are the same and match the sign of the middle term. If third term is negative, the signs are opposite. If the third term is negative, the signs are opposite. So that'll take us through step 3. Step number 4. Find the factors of the first and third term. And step number 5, plug in and check. So we can go through these steps for any of these quadratics, these second degree polynomial functions, and be able to factor them by using these steps here. So when we look at this first example, we want to factor 5x squared plus 15x plus 10. Now our first step in factoring this down is to see, is there a greatest common factor? Is there a number or variable in common with all three terms? If there is, we can factor it out. 5, because 5, 15, and 10. 5 will go into all three. 5 is a common factor of 5, 10, and 15. So the first thing we're going to do is factor it out. We're going to divide each of the terms by 5. 5x squared divided by 5 is going to be x squared. Now, since we're dividing by positive 5, we're not pulling a negative out. The signs are still going to be the same. So we'll still have a plus between the x squared and x. So 15x divided by 5, 15 divided by 5 would be 3, and we still have our x plus 2. Because if we factor 5 out of 10. 10 divided by 5 is 2. Is there any other greatest common factors with our x squared plus 3x plus 2? So that takes care of step number 1. Step number 2, we need 2 sets of parentheses with 3 spaces. Now we still need the 5 out front because it is still a part of this quadratic, this polynomial. It's still part of the factor. Well, that takes care of step number 2. Questions on steps 1 or 2 so far? Step number 3, find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So our third term in this case is 2, yes? Because that's our third term. And the 2 is positive or negative? Positive. So the signs are the same and going to match the sign of the middle term. So our middle term in this case is 3x, yes? And 3x's sign is what? Positive. Since the third term is positive, the signs are the same and match the sign of the middle term. So we have plus and plus. So we take care of steps 1, 2, and 3. Step number 4 is what? Find the factors of the first and third term. Our first term is x squared. Well, the factors of x squared, what multiplies together to get us x squared is x times x. 1 times x squared is a factor of x squared, but it does not help us with factoring these polynomial functions. Our third term is 2. Yes. Thank you. Third term is 2. Only factors of 2 are, well, 1 and 2. And that takes care of steps 1 through 4, yes? The only step we have left is what? Plug in and check, yes? Now, plug in and check. All that means is we're going to take one of the factors of x squared, our first term, and we're going to plug it in. Well, the only set of factors we have for the first term is x and x, yes? So we'll plug those in the first spot. Our factors of 2 are 1 and 2. So we'll plug those in. Now, the big question at this point, where does it, we're supposed to plug the first term in, where are we supposed to plug the second term in, does it matter? And at this point, no, we need to plug them in because the last thing we're going to do is check it. We're going to make sure we have it right. Because when we check it and we get the correct, we get back to what we started with, well, in this case, our x squared plus 3x plus 2, we factored it correctly. If not, we're going to change the terms. We're either going to change the factors of the third term, we're going to flip them, try different factors, or we're going to flip the first term's factors and try it again. Okay? Now, most books say when we check this here, that we need to multiply all the way back out. And see, do we get back to x squared plus 3x plus 2? I don't see a whole lot in doing a whole lot of the point into multiplying the whole thing back out. Specifically, 2 main places. Bless you. X times x is going to be what? X squared. Well, where did we get the x and x? From factors of x squared, yes? Well, the factors of x squared multiply together to be x squared. So they should, again, still multiply together to be x squared. Is there any point in really checking that? No. 1 times 2 is 2. Well, where did we get the 1 and 2 from? The factors of 2. So the first and last really give us the first and last term. Well, we got those numbers from the factors of the first and last term. So they should get us back to where we want. So when I check this, the main place I check is going to be x in 2 here and 1 in x. I'm going to be checking for the middle term, that 3x. because it's going to be the main one that changes in how we have it set up based off the factors. So if we do this here, x times 2 is 2x, and it'd be positive. Then we have 1 times x, which is positive 1x. So we have 2x plus x, which is 3x. Is that the middle term we wanted? So that tells us 5 times x plus 1 times x plus 2 is the factored form of our 5x squared plus 15x plus 10. Questions on this here? You ready for the next one? 4x squared plus 32x plus 60. First step, greatest common factor. So we have 4x squared plus 32x plus 60. So is there a number that goes into all three? Because 4 will indeed go to 4x squared, 32x, and 60, yes? X, there is no variable across all three. 4x squared does have an x. It's actually 2 of them. The middle term does have 1x, but our 60 does not have a variable. So the only greatest common factor that we have for this here is 4. And we're going to divide it out of all three. We're going to simplify it out. Because if I simplify or factor out 4 from 4x squared, we're left with x squared. Now, since 4x squared, our first term was positive, we're not going to worry about taking a negative out. But if I factor 4 out of 32x, 32 divided by 4 is 8x. And lastly, we can divide 4 out of 60 and get 15. Because we could have done this in a calculator, said 32. 32 divided by 4, 60 divided by 4, 8 and 15. Because that's all we're doing is just dividing that number by 4. Are there any other greatest common factors left? No. So that means we can move on to step number 2, which is our 2 sets of parentheses with 3 spaces. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the sign of the third term is positive. So the signs are the same and going to match the sign of the middle term, which is also positive. So we have plus and plus. Step number 4 is to find the factors of the first and third term. Well, our first term is x squared. And its factors are x and x. Our third term is 15. We're not looking back at 60 because we're trying to factor the x squared plus 8x plus 15. Because we factor that factor of 4 out, so we've reduced it. We're looking at the new one. Now, factors of 15, we do have more than one. But I would always start with 1 and 15, and then go up from there. Is 2 a factor of 15? Can we divide 15 by 2 evenly? No. How about 3? It'd be 3 times 5. The next possible factor would be 4. 4 does not work because it'd be 4 and 4 point a decimal, 4.75. And we're done because the next factor after 4 would be 5. 5 is already listed, so these are our 2 sets of factors. Now, the nice thing with this here, and especially when we plug it in, if there's only one set of factors, just throw it in. X squared's only factors are x and x. That's the only way it works. That variable being squared, x and x, v squared would be v and v. We could actually just throw it in. Even if it was, say, 4x squared, we can just throw the x and x in and then worry about the factors of 4 later. Now, our factors of 15 are 1 and 15 or 3 and 5. We need to pick one. No, pick one of them. 3 and 5. And the reason I say it doesn't matter, because it does matter and it doesn't at the same time, because our step number 5 is what? Plug in and check. Because if 3 and 5 are the correct factors, when we check it, it will tell us that they are. And if they're not, it will tell us that they're not, and we can switch it, we can change it. And again, I'm still going to check the outer and inner. Because x times x is still x squared. 3 times 5 is still 15. Here, x times positive 5 is going to be positive 5x. Positive 3 times positive x is going to be positive 3x. And 5x plus 3x gives us 8x, because that's the middle term we wanted. So these are the correct factors. Four times x plus 3 times x plus 5. And with these here, 4 is still part of the factored form because it is the greatest common factor. It is a factor. We need all of it. Questions on this here? Let's look at this next one. 4x squared plus 13x plus 3. First thing we need to do is check for greatest common factor. It does not have one. Is A negative? No. A is going to be our number in front of x squared. It's positive because we want that first term to be positive, so we're good there. So even though there's not a greatest common factor, we're going to move on to step number 2. Our 2 sets of parentheses with 3 spaces. We do this here mainly just to give us enough space to fill in all of our information. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, the third term sign is positive, so the signs are the same and match the sign of the middle term. And incidentally, it's also positive. Questions on steps 1, 2, or 3? Step number 4 is to find the factors of the first and third terms. So we have 4x squared and 3, yes? Well, wait a minute, what are the factors of x squared? X and x. Are there any other factors of x squared? No, so I know that this first term is going to have x and x. I am always of the mindset, less unnecessary work, the better. Because we could come over here and say 4x squared. And the first one would be 1x times 4x. The other factors of 4x squared would be 2x and 2x. Well, we have x and x every single time, yes? So what we could do is just plug the x squared in, because that's going to be included already. And instead of finding the factors of 4x squared, we just find the factors of 4. Because that x and x from x squared is going to be a part of each factor every single time, so might as well just stick it in to our factored form and just worry about finding the factors of 4. Factors of 3 are 3 and 1, 1 and 3. Are there any others? No. It's prime, so there's only one set of factors, 1 in itself. Now the question is, which one do we want to use? Well, 3, I only have one set, yes? I'm going to plug them in. we can throw it in because we can do 1 and 3 or 3 and 1. We just need to pick one and choose it. Because our factors are 4, 1 and 4, 2 and 2, yes? Pick one of them. 2 and 2. Because at this point here, I would not get bogged down about which one's better, which one's not, which one should we choose, which one shouldn't we choose. It's just pick them. Now, as you do more and more of these, you'll start seeing patterns and start recognizing what is going to be a better choice, what is going to most likely be the correct set of factors, and go from there. Because again, what we're going to be doing is trying to get to that middle term. And the middle term for this here is 13x. 2x times 2x is still 4x squared. 2 times 2 is 4. X times x is x squared. No reason to check that. 1 times 3 is still 3. Now we check this here, 2x times 3. 2 times 3 would be 6. And we have our x. And it would be positive. 1 times 2x, positive 1 times positive 2x is going to be 2x. 6x plus 2x is 8x. Is that the middle term we wanted? No. Now, since it's not the middle term we wanted, we can go back and look at the form we had. 2x plus 1, 2x plus 3. First thing we could possibly do is switch the 1 and 3. But would that do anything for us here? No, because if I did switch it, there's these here. Well, I'd be multiplying 2x and 1 and 3 and 2x. So most likely, yes. We're going to have to switch the 2 and 2 to 1 and 4. You want to put the 4 in with the first x or the second x? First x. Because again, at this point, we can check and make sure 4x times 1 is going to be positive 4x. Positive 3 times x is going to be positive 3x. Which will give us 7x. Is that the middle term we wanted? No. So the last thing we can do is switch to 1 and 3. Giving us this here. 4x plus 1 times x plus 3. So now we're going to multiply what? 4x and 3. 4 times 3 is 12. We still have our x. 1 times x is positive 1x. 12x plus x is 13x. Is that the middle term we wanted? Yes. And that's it. So some of these here, we're going to have to try several different arrangements of the first and third terms factors to try to get to that middle term. Questions on this here? All right, let's look at the next one. 3x squared minus 7x plus 2. Is there a greatest common factor between these three terms? Because 3x squared, 7, and 2, well, 3 and 2 are both prime. They don't share anything with 7. So there is no greatest common factor between these three terms. So we can write our two sets of parentheses with 3 spaces. Third step's find the sign. If the third term is negative, the signs are opposite. If the third term is positive, the signs are the same and match the sign of the middle term. Is the third term sign positive or negative? Positive. Yes. And the third term is indeed positive, yes? So the signs are going to be the same and match the sign of the middle term. Now this time the middle term is not plus, it is negative. So that means both signs are negative. Questions on this so far? Fourth step is to find the factors of the first and third term. So our factors of the first term are 3x squared. Well, we know the x squared has to be what? X and x. So we can fill that x and x in because there's only one arrangement of it. So we can fill it in. If writing it out helps, write out the factors. Because we could do the whole thing 3x squared because it'd be x and 3x. And that's it, because x and x are the only ones. Factors of 3 are 1 and 3. That's it, yeah? So we just have to plug the 1 and 3 one of the two spots because those are the only factors with 3x squared. So, do we want to put the 3 with the first x or the second x? The first one. Now we can put the 1 with our second x. Because I can say that it's 1x, but it's understood to be 1x if we just write x. So we don't necessarily have to write the 1. So we have 3x and x. What are the factors of 2? 1 and 2. So we can just plug them in. Where do we want to put the 1? Where do we want to put the 2? 1 in the first spot or the second one? First. We can put 1 here. 2 here. And again, I would just plug them in. Because the more of these that you do, the more that you'll kind of see how the numbers are working, how they're going together. Because, again, no reason to check the first multiplication, 3x times x, positive 3x times positive x is still positive 3x squared. Negative 1 times negative 2, the negative and negative would make a positive. 1 times 2 is still 2, so we still get the first and third term. 3x times negative 2. 3 times negative 2 would be negative 6x. Negative 1 times x is going to be negative x. And negative 6x minus x is negative 7x. Is that the correct middle term? Questions on anything we've done so far? Be ready for the next one. 2x squared plus 7x plus 6. Is there a greatest common factor between these three terms? Because 2x squared and 6, yes. We can divide 2 out of it, yes? But not 7. So first and third term, yes, there is a greatest common factor, but the middle term does not have a greatest common factor. Since there is no greatest common factor, we'll have 2 sets of parentheses with 3 spaces. Our third term, we need to find the signs. The third term is positive, so the signs are the same. You're going to match the sign of the middle term. Positive. Middle term is positive, so our signs are going to be plus and plus. Now we got to find the factors of the first and third term. Well, 2x squared, we know that we'll have x and x because that's the only factors of x squared. Our factors of 2 are 1 and 2, yes? So we could write them out, or we can just fill in 2 and 1. Only one set, so there's only one choice for me to make. 2 and 1 are the only factors that I can plug in that first spot, so might as well just go on and plug them in. Factors of 6. We can have 3 times 2 or 1 times 6. We have 1 and 6 and 2 and 3. Which one do we want to try first, 1 and 6 or 2 and 3? 2 and 3. Do we want to put the 2 first or the 3 first? 2 and 3. Because our last step is to plug in and check, yes? Now 2x times 3, 2 times 3 is going to be 6x. 2 times x is going to be positive 2x. So we had positive 6x plus 2x is 8x. Is that the middle term we wanted? No. But before we erase this here, let's look at the first set of parentheses. What do we have? 2x plus 2. Is there a greatest common factor between 2x and 2? Yeah, that factor is 2. So even in parentheses, we could actually factor that 2 out, and it would tell us that we have 2 times x plus 1 times x plus 3, because if there's a greatest common factor in those, we could factor it out just like the beginning, yes? Was there a greatest common factor to begin with? Well, no. If there's not one to begin with, we can't have one in either set of parentheses. So that leads to the question, why would that make a difference? Well, we'll switch the 2 and 3 here in a second. But could I put 6 with 2x? No, because 2x and 6 have a greatest common factor of 2. If there's not one to begin with, there can't be one in either set of parentheses. Now, before we try 6 and 1, we can flip the 3 and 2. Because now we have 2x times 2. And 2 times 2, or 2x times 2, would be positive 4x. 3 times x would be positive 3x. And 4x plus 3x would give us 7x. Is that the middle term we wanted? So 2x plus 3 times x plus 2. Now, seeing the fact that there's no greatest common factor means that there can't be one in either set of parentheses does help us to be able to try to eliminate some of the factors we have to check, some of the ones we have to try. And if that makes sense, awesome, use it. If not, we saw also that still checking it told us that it did not work. Either way works. Questions on this here? (4x squared minus 7x plus 3). So the first thing we need to determine, is there a greatest common factor between these 3 terms? Well, no. So that means we can move on to our 2 sets of parentheses with 3 spaces. Now, since the third term is positive, the signs are the same and going to match the sign of the middle term. And the middle term is negative. So we'll have minus and minus. Factors of the first term, factors of 4x squared. Well, we would have x and x. However, 4 has 2 sets of factors, 1 and 4, or 2 and 2. Well, we can try 2 and 2 first. Our factors of 3 are 1 and 3. Since there's only one set of factors, we could just pick one of them and plug it in. And the last thing we need to do is check. 2x times negative 3 would be negative 6x. Negative 1 times 2x is negative 2x. Telling us that we have negative 8x. That is not the middle term we want. So we're going to switch from 2 and 2 to 1 and 4. Well, 4x times negative 3 would be negative 12x. Negative 1 times x would be negative x, giving us negative 13x. So the only thing left that we can switch is the 3 and 1. And 4x times negative 1 would be negative 4x. Negative 3 times x would be negative 3x, telling us that we have negative 7x, which is indeed the middle term that we wanted. Questions on any of this here? All right. We are going to keep doing factoring, but that is it for today. 3 through 10. 3 through 10. If you've not turned any of the assignments in for Chapter 2, you have till the end of the day today to turn them in. Otherwise, or unless we've talked, otherwise they're becoming zeros.